Good evening. Welcome to the another session of mathematics. And in this session, we'll continue from question number 56. Let's go ahead. So right now here I have, this is one of the angles here. So between 0 to pi by 6. And then I need to see if a into secant of a is less than this quantity. Similarly for a and b, and then for a, b, and c. So for this thing, of course, we're going to see some graphical approach. So if I just look at the first problem, then it is talking about a into secant of a. So a into secant of a, I can think of a over cos a kind of thing. That means I should be discussing about cosine graph. So I'll just simply draw the graph of cosine. So it's the graph of cosine here, right? From 0 to pi by 2. Now, the angle is going on, a is only between 0 to pi by 6, so this is my pi by 6 somewhere. This is my pi by 6. So this is my point. No, that's ultimate some other point, because a is reserved. So this is my point, P. And now my a is floating anywhere here. Okay, it's anywhere in between 0 to pi by 6. This is going to be my a. So now this point I'm going to have here, so a comma cos of a, and this point is going to be p comma cos of p on the graph. So now if I just look at their slopes quietly, so this is the slope. Here I have OA. So if I look at the slopes, then of course this OA theta will be definitely more than this theta. So slope of OA is going to be more than slope of OP. So now just plug in here. So slope of OA is going to be what? So it's simply, this is 0, 0, I'm taking. Now I'll find the slope here. So this turns out to be cos A over A is going to be more than, if I find the slope of OP, then P value is pi by 6. So I just need to plug in here pi by 6. So pi by 6 is 30 degrees across 30 is root 3 by 2. So let's plug in here. So this will give me root 3 over 2 over pi by 6. So now if I just simplify this a bit further, then I need to talk about A over cos A. So first we can visualize this thing. 6 root 3 over 2 pi will give me 3 root 3 over pi. So now my cos A over A is more than 3 root 3 over pi. So since all these are positive quantities and there is no zero involved, that means I can just take the reciprocal. So A over cos A is going to be less than pi over 3 root 3. So that means my option statement of statement 1 is correct. Now, if you have understood this logic, then I believe we can go and try the remaining two. So between 0 to pi by 4, I have A and B. So we need to talk about A cosec A and B cosec B. So it seems that I'll be doing the same step, and then I'm going to add both the inequalities, because ultimately they're positive, so we don't have to worry about anything. So, but here A into cosec A is involved. So A into cosec A should remind you of A over sine A. That means now I'll be taking the sine graph. So let's take the sine graph and then see what do we get. So this is my sine graph. And then this guy right here is my pi by 4. So also this is my point B. And my A and B both are here. So I'll just plug in any one of them, A or B. So my A can be anywhere between this. So say my A is here, because I'll be getting it here. So let's put this point. So A comma sine A. And this point will be what? B comma sine B. So now if I take help from slope again, then I look at this thing and I look at this thing. So here also, if you see carefully, the OA slope is definitely more than OP slope. Slope of OA is again more than slope of OP. Even in this case, so what happens? OA slope is sine A over A. So sine A over A is more than pi over 4. So P is basically what? Pi over 4 and then 1 over root 2. So it's 1 over root 2 by pi over 4. And this gives me Sine A over A will be more than, so it's going to be 4 by root 2 pi. And this could be further even rationalized by writing here root 2. So we get here 2 root 2 over pi. So now I know my sine A over A is more than 2 root 2 over pi. So if sine A over A is more than 2 root 2 over pi, which means A over sine A would be less than the reciprocal. So pi over 2 root 2. So pi over 2 root 2. And similarly, B over sine B will be also less than pi over 2 root 2. Of course, they are positive. So therefore, if I add both of these inequalities, I'm going to get A into cosec A plus B into cosec B. It's going to be less than pi over 2 root 2 plus pi over 2 root 2 will give me pi over root 2. So that means my statement 2 is also correct. Now here the guy is A into cot A, and B into cot, and C into cot. So of course I can do the same step. But now I have to deal with tan. So let's see for tan, and then we'll simply add all three inequalities to get the final result. So for tan, I'm going to get something like this. And my all the angles are between 0 to pi by 3. So we set the border here somewhere pi by 3. This looks pi by 3. Pi by 3. Now I'll just take any point here. So this is A. This one, and then we have point pick another one. So if we see the slope here and slope here, so this time, so suppose this is my point P, then it's P comma tan P, and this guy is right here is here is 3. So this point would be A comma tan A. So now let's simplify the slope. So we can see here the slope of OP this time is going to be more than slope of OA. So slope of OP will be, this is pi over 3, and then tan 60 is root 3. So it's going to be root 3 upon pi over 3. This is going to be more than OA. So OA is going to be, slope of this thing is going to be tan A over A. Tan A over A. Well, if I have tan A over A, I can simply reduce this guy. Then this will give me basically 3 root 3 over pi is going to be more than tan A over A. So if I take the reciprocal, I think we need to talk about A cot A, yes. So we'll take the reciprocal here. So if I take the reciprocal, then I get here A into cot A is going to be less than pi over 3 root 3. So if I add all the three, say for B and C, so I get here pi over 3 root 3, pi over 3 root 3, pi over 3 root 3. So that means if I just add all of them, so A into cot A is going to be less than pi over root 3. And this makes our third statement also correct. So now the question is the collection which is true. So yes, A is correct option, B is also correct option, and this says that 1, 2 only, but not 3. So this is incorrect. And it says all of them, so yes, 1, 2, 3 is correct. So D is correct. Move to the next problem. So here we have another one. And let me the least value of this quantity for positive values of x and y such that x squared into y cubed is 6. And there is a pack containing all those n cards, level 1 to 3 to n. And the 3 cards are drawn from at random, delivered by ABC. And this condition is A is more than B is more than C at a time from the back, and then the probability that this integration becomes 0. So this probability we need to find out. So let's go ahead. We want 3x plus 4y. So we want the least value of 3x plus 4y for positive values of x and y. The word itself is enough because we are saying that positive values of x and y, and we need the least value of this quantity, which means A and GM has come into the picture. So since this is given to be x squared into y cubed, so that means here I should be adding, when I multiply, I should get x squared. That means I need to divide this by 2, so 3 is over 2, 3 is over 2. So I'll use weighted AMGM, basically. So weighted AMGM, that means I need to produce three y's and two x's when I multiply. So for that, we need to use here 3x over 2 plus 3x over 2. Now when I multiply then in the GM, I'm going to get x squared. And then for 4y, I'll be writing 4y over 3 plus 4y over 3 plus 4y over 3. This over 5 will be now greater than or equal to the fifth root of this product. So which is 3 square over 2 square, and then 4 cube over 3 cube, and then 4 cube, 3 cube, and then x square into y cube, right, which is 6. So now let us see. So this quantity will be 3x plus 4y will now be greater than or equal to 5 times the fifth root of, so this is 3 square and this is 3 cube. So here 3 survives and this 3 will now cancel this 2. And then this is 2 to the power 6 and 2. So this is 2 power 7 over 2 power 2. We give it 2 power 5 inside. So the fifth root. So this is like 2 power 5. So now therefore I know that 3x plus 4y is going to be greater or equal to 5 into 10, 2, which is 10. So that means n is equal to 10. So now once we have unlocked this part, so now it requires that there are 3 cards randomly chosen from this bag. So this bag contains basically numbers like this 1, 2, 3, and so on up to 10. So now we have to choose 3 cards randomly. So and of the samples, this is going to be 10C3. This one is locked. Now what is next? So we need to choose as that this integration. So let E be the event. So let E be the event. That probability that integral 0 to a x square minus 2bx plus 3c into dx times dx is equal to 0. So this is my event now. So let's go ahead for the event. So 0 to a, and then we have x square minus 2bx plus 3c. So x square minus 2bx plus 3c dx is equal to 0. Let's go ahead. So I'll simply integrate this. So we get here a cube over 3 minus, this is going to be x square means a square, and here this will be b, and 2 gets cancelled. So okay, and then 3ac is equal to 0. So which means I get a cube over 3 is equal to a square minus 3ac. So here I can get rid of the a's. So I get a square over 3 is equal to a minus 3c. One of my a's got cancelled. So let's go. So here now we need to find out the condition on ABC that when this is satisfied. So for that, we'll consider fixing this thing. So I see that a square, all ABC are integers. So all these ABCs are integers. So that means right side is an integer, so left side is also an integer. So LHS is also an integer. So this is an integer, that is what I should be having. I can have a is equal to a square should be multiple of 3, which means a should be 3. I can take a is equal to 6, and I can choose a equal to 9. So these are the 3 possibilities here for a. So let's plug in a equal to 3. So here I get 3 square, which is 9 over 3, which is again 3 is equal to a is 3. So I get 3b minus 3c. So which means b minus c is equal to 1. So when b and c are 1, and I need to solve this. So since already I have taken a is equal to 3, and this is the greatest number, greatest of all ABC, because a is more than b is more than c. So accordingly, I'll choose b and c. So b could be 2, and c could be 1. So here we get one pair, which is 3, 2, 1. So this is one pair now we've got. And of course, this is an ordered pair, by the way. The 3 cards we are drawing, but this turns out to be an ordered pair because we cannot interchange them. Now, when a is 6, let's plug in. So 6 square is 36 over 3, which will give me 12. Is equal to 6b minus 3c. So I can cancel 3 also by writing here 4 and then here 2b minus c. So A is 6 and we want this to be minus 6 should be 4. So accordingly, we'll choose B and C. So B should be, we can choose B to be 3. So that 6 minus 2 will give me 4. So in this case, I get 6, 3, and 2. And when I choose A equal to 9, we can plug in here. So A square, 81 over 3 is going to give me 27. So 27 is equal to 9B minus 3C. Again, I can divide by 9. So I get 9 is equal to 3B minus C. So since A is 9, that means I can choose B is equal to 4. So that 12, and then C I'll choose 3. So that A is more than B is more than C. So in that case, I'll be having 9, 4, and 3. And if I choose B equal to 5, so this is 15 minus 6. Minus 6 is again 9. So if I choose B is equal to 5, suppose. So if I choose B equal to 5, then this is 15. And C I can choose to be 6. C I can choose 6 again. So 15 minus 6 will be again 9. So this part is also satisfied. That means I get one more pair. So 9, 5, and 6. Can we choose 6? So 18 minus C should be 9. But then in that case, it will be incorrect because A should be more than A is more than B is more than C. But here again, this part is also in unknown. I mean, will be lost because A should be more than B should be more than C. So this part also won't be there. Though it's a solution, but it fails to satisfy the constraint. That means only three of them are there. So therefore, probability of V will now be equal to just simply 3 over 10C3. So 10C3, we can get it. So 3, 10, 9, 8 over 3, 2, 1. So 3 and then 2, 4. So this will be 120. So 3 over 120 will give me 1 over 40. So it is 1 over 40. That means P over Q and GCD is 1. So therefore value of P plus Q. So 1 over 40. That means if I add it, so I get here 41. So the answer would be 41. Okay, for the next, here we go. So we have this series n equal to 1 to 99, natural log of n square plus 2n over n plus 1 square. And this series is given to be ln of P over Q, so that GCD of P comma Q is 1. Then we want the number of solutions of this equation, that f of x is 0, where f of x is equal to this thing. So that means we need to find the sum of this series before, because without this, we cannot even start the question. So we don't know what is P and Q. So consider this guy. Sigma n is equal to 1 to 99. It is ln of, so it's n square plus 2n. I can add 1 and subtract 1 later. And this is n plus 1 square. So if I go ahead with this, I'm going to have n is equal to 1 to 99. So simply ln of, so give me 1 minus 1 over n plus 1 square. And this could be further written as sigma n is equal to 1 to 99. It is ln of 1 minus 1 over n plus 1 into 1 plus 1 over n plus 1. Now, this is ln of the product. That means this could be written as further. So, this is going to become the ln of the product. So I can now write down this is equal to ln of this product. So n is equal to 1 to 99. And now I have here 1 minus 1 over n plus 1 into 1 plus 1 over n plus 1. So this can be further written as into, now let's write down all these terms here. So I'm going to, when I plug in here 1, I get 1 minus 1 over 2 into 1 plus 1 over 2. Next will be 1 minus 1 over 3 into 1 plus 1 over 3. 1 minus 1 over 4, then 1 plus 1 over 4. We just would continue up to, so 1 minus 1 over, this is 100 into 1 minus 1 over 10. That's what we get. Now let's go ahead and I'm now going to simplify this guy. So if I simplify this further, then this would give me So this would be equal to ln of, let's write down these values, but we have got 2 minus 1 is going to be 1 over 2, and then this is 3 over 2. So 1 over 2 into 3 over 2, what it is, 2 over 3, 4 over 3. So 2 over 3, 4 over 3, 3 over 4, 5 over 4. So 3 over 4, 5 over 4, and this will go on up to the last value is going to be 99 over 100 and 100 over 101. 100 over 101. So we get. And now if you see it carefully, then this 1 over 2 will be left aside, and then the rest all of them will get cancelled except for the last term. So I'm going to get here ln of 100 over 202. So it is going to be 100 over 202. So 100 over 202 I have here. And now this is P over Q. So of course 100 over 202 will be left. We need to simplify this in the further format. ln of 100 over 202. And now if we look at this thing, then this works. This area of P over Q should be 1. So we need to reduce in the simplest form. But we know this is plus 5. So it's 1 plus. Oh, that means this value will change now. Okay. So it's going to converge. So 1 0. This one was and it's 99. Okay. This value is already incorrect. It is going only to 99. So this will be 100. 99 plus 1 is 100. And this is also 100. So this will be at 101 over 100. So 101 over 100. So this part will give me 101 over 200. Okay, that means this is already in the lowest form, so there is no point of this idea of P and Q. So we have saved ourselves. What is next? Okay, so P and Q we have found already. Now we need f of x is equal to, so therefore f of x is equal to x cube minus, this is 2p minus q plus 1. 2p minus q plus 1. So this is p is equal to 101 and q is equal to 200. So if I add multipliers, I get 202 minus 200. So 2 plus 1 is going to be 3x. Then, okay, so this part will become 0 and then plus 1. So we have got this thing. Now we got the zeros of f of x is equal to 0. So f of x is equal to what? 0 to what? No. So first we'll try to plot the graph of f of x and see the zeros of f. So if I differentiate this, so I get f dash x is equal to 3x squared minus 3 equal to 0, which means x is equal to 1 and minus 1. So these are the critical points. And if I look at the second derivative, then this turns out to be 6x. So this is my minus 1, this here is 1. Now if we look at this, then at 1, I'm going to get minimum. So f of 1 value is 1 plus 1, 2 minus 3 is minus 1. So at 1, I'm going to get minus 1. And minus 1 second derivative is positive. That means, oh no, second derivative is negative. So double dash of minus 1 is going to be minus 6, which is negative. So x equal to minus 1 is a point of maximum. So f of minus 1 is going to be 3 plus 1, 4 minus 1 is 3. So this is going to be 3. So that means if we draw the graph of it, this is x cube, so its range is r basically. So that means I'll be having the graph will go somewhat like this because it should start from bottom. And now since it is achieving its minimum and they have opposite sign, that means the graph must pass between them. And then it will go ahead like this. So this would be the graph of f of x. And now if we look at this, then we just simply plot this. This is minus 1 here. And f of 0 is 1. So say this region is my 0. So this is 0. This is 1. So now if you look at this, then we want f of x is equal to 0. So this is f of x is equal to 0. Its roots are, say, this is my alpha 1. This is my alpha 2. And here comes my alpha 3. So if we want this to be 0, then I have to say when my f of x becomes alpha. Because f of alpha will become 0. So alpha I need. So f of x should be equal to what? Alpha I. So I know my first alpha 1 belongs to what? It's somewhere between minus, this is minus, of course, less than minus 1, but more than minus 2, we can say, because minus 2 is it's going to give me positive here. No, it's too late. So negative only. That means there is a root here. So the first root, alpha 1, we can say belongs to minus 2 to minus 1. We can say. Or even if you take some other value also, it's not a problem. Yeah, I mean, minus 1 to 0, I can also take some other value also, but since this looks standard, then alpha 2 belongs to, it's between 0 and 1. Or you can check it by Bolzano property, or you would, let's say, intermediate value property. And my third root is between 1 to 2. Third root is between 1 to 2. So if I just plot the graph alpha 1, alpha 2, and alpha 3 and see the point of intersection at them. So I plot alpha 1. So alpha 1 is from minus 2 to minus 1 basically. So we'll start the graph here. So it will be like this. So if we plot the graph for alpha 1, so if I take any value between minus 2 to minus 1, this value is minus 1, I know. So that means I have to draw any value between minus 2 to minus 1. Okay, should not cross this. That means I'm going to get one line here for alpha 1. And alpha 2 is between 0 and 1. So between 0 and 1, I can plot anywhere line because we do not know what it is. But between 0 to 1, I have it here. No, 0 correct because 1 is here at this point. So I'll plot it here, right? So this is my alpha 2 now. And alpha 3 belong to 1 to 2. So it's above 1 to 2. That means I'll be having one more line here from bottom. So it will go like this. This is my alpha 3. Now what is next we have? Already we have found. So when my f of x becomes alpha I, then f of alpha becomes 0. So in that case, I'm going to get here 1, 2, 3, and here 4, 5, 6, this will be 7. So we get here 7 solutions. So the number of solutions are coming 7. 7 will be the correct answer. Let's go to the next one. So this is 59. And here we are given a matrix. So A is equal to 1, 1, 1, 0. And A to the power n is mentioned this way. That we're going to have here, so Fn plus 1, Fn, and then Fn and Fn minus 1. And F1 and F2 is 1, and Fn plus 1 is equal to Fn plus Fn minus 1. So this is basically called as the Fibonacci sequence. So Fibonacci sequence is like suppose I want the nth term. So nth term is the addition of previous two terms. So say I'm starting this one is 1, 1, and then next one is going to be 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 13, and so on. So this is my Fibonacci sequence. And we want F101. That means somehow I need to get 101 into the picture. So if I set n is equal to 100, so I get a power 100 is equal to F101 and F100 here. This will be again F100. This will be F199. And into F201. That means I need to bring 201 also. So I'll set n is equal to 200. So if I do this, I get A200 is equal to F201, F200. Here also F200. And here F199. And now So if I want to see them added in this format, that means F101 into 201, so I should be multiplying this. So a power 100 into a power 200 will be equal to F101, F100, F100 again, and F99 here. This into F201, F200, F200 again, F199. This when I multiply, I'm going to get, here I'll be getting A300, and A300 is basically, if I use this one again, so that's going to give me F301 and F300, and here also F300, and here F299. This would now be equal to, let's perform the simple matrix multiplication. So this is going to give me F101 into F201 plus F101 into F200 plus F100 into F199. But then if you look at this, then we just need the, this is 100 actually, F100 into F200. So F101 into 201 plus F100 into F200. This looks like the first entry of this matrix must be equal to this. So I get F101 into F201 plus F100 into F200. This must be equal to F301. So if I just divide this, then I get here 1. This problem was actually easy. Just required a way to think. There's no point of viewing this matrix. Ultimate no issues. Let's go to the next problem. Question number 16. Now look at this. This problem looks so cute. We have here limit n tends to infinity, and this is n plus 1th root of n plus 1 factorial minus nth root of again n factorial. So this looks like just consecutive terms, and they are going to approach some particular value. So they are consecutive terms. And we want to say that where is this function actually approaching when my n tends to infinity. So this is a kind of sophisticated limits. And for that thing, now, of course, we need to think of something here. So I'll take a sequence an is equal to n over n factorial, nth root of n factorial. If I take this sequence, now, of course, this is sequence of positive terms. Because intention is, so it is of the type some an plus 1 minus an. It is of this type. So we have limit n tends to infinity, an plus 1 minus an. So if we look at this thing, then this gives the intention of Stone's Arrow theorem. So if I look at Stone's Arrow theorem, then what is Stone's Arrow theorem? So if I have an and bn are two real sequences, bn are two real sequences, and bn is monotonically increasing. So bn is monotonically increasing. And it should be divergent. This limit n tends to infinity, bn should also go to infinity. Then, and if limit n tends to infinity, an plus 1 minus an over bn plus 1 minus bn is equal to L, then limit n tends to infinity, an over bn is also L. This is what my Stokes' theorem is. So looking at this an plus 1 minus an, this gives me the idea that I can think of. So I have got an now. That means I need to find out the blind partner. So this could be always written as 1 here. And if I just write down increasing sequence like this, n plus 1 minus n, that means we are in the proper Stokes' form. So uh, let an is equal to, of course, n root of n factorial we have got, and bn is equal to n. So now we can apply by Stokes' law. So what do we get? limit n tends to infinity, an over bn. So that means I'm going to get here limit n tends to infinity. This is nth root of n factorial over n. Now to solve this one, we will apply Cauchy's theorem. So Cauchy's second theorem on limits. So Cauchy's second theorem on limits. Cauchy's second theorem on limits. So again, so if my an is a sequence of a and bn positive sequence, a and bn positive sequence of real numbers such that limit n tends to infinity, an plus 1 over an is L, then limit n tends to infinity, an to the power 1 over n is also L. So it looks like n to the power 1 over n. Now, how the limitation comes? So if we look at this thing, so I can write n factorial over 1 over n, and this n could be written as n to the power n over 1 by n. So if I consider this part, then I'm going to get here limit n tends to infinity, n factorial over n to the power 1 over n. Now this is my a n basically. So a n is equal to n factorial over n. So now instead of finding this thing, we'll find out a n plus 1 over a n. That's quite easy to calculate, or you can do it even by using limit as a sum concept. You can simply take the log on both sides and then use that integration to get the limit, or you can use Cauchy's theorem. In fact, if you're well versed with what is Cauchy's theorem and Stone's theorem. So this is going to be n plus 1 factorial over, so this is power n. And power n. So this is going to be n plus 1 power n plus 1. This is my an plus 1. And an is going to be, I'll write down the reciprocal, so this will be n power n here, and then n factorial here. So now n plus 1 into n factorial is going to give me n plus 1. So this gets cancelled. So and now I have limit n tends to infinity, n over n plus 1 to the power n. This could be written as limit n tends to infinity, 1 over 1 plus 1 upon n to the power n. And this will give me 1 over e. So the final answer would turn out to be 1 over e. So the problem looked cute, but it has insane solution. Anyway, do let me know in the comments if you have some other method to apply. Thank you so much for watching. Happy learning. See you.